All right, good morning, everyone. Oh, do we have a treat for you today? I'm going to publicize for the first time my hidden talent of mind reading. And since this is a magic trick, you know, every magician needs an assistant. And I want to introduce Billy Moses to you. Billy is a PhD student. He already has 3 degrees from MIT, but he wants a 4th, I guess. And so I'm going to turn it over to Billy here. And Billy's going to sort of set things up. I'm just going to do my thing, which is read your minds, okay? So go ahead, Billy.
So what's going to happen is I have this card deck right here, normal card deck, perfectly normal cards. They're not in any weird order. You can see them. I'm going to give 5 people the opportunity to pull a card and then give it back to me. They can look at the card. Then what's going to happen is I'm going to turn over 4 of these cards, show you the final card, and then Srini's going to try to guess the 5th card.
Well, but what I need you to do is, when I'm going to guess, I need all of you to really focus on that hidden card. I mean, in your heads, right? So I can't do individual mind reading, just in case you guys were worried. You know, so if you think I'm wearing a terrible colored shirt, I'm not going to know. Okay? But if you all think of this, this hidden card, I'm going to be able to guess it. But so I need some help. All right?
Okay. Anyone wants to try pulling some of the cards? Okay.
And I guess
Take your favorite card.
I can step out here, right?
Yeah.
All right.
You can look at it, give it back to me. Once you've, cool. Anyone else want to pick a card? Pick a card. There you go. You can look at the full deck. Look at whatever card you want. Pick it. Cool.
Hi. You're doing a little.
Anyone else want to pick a card? You want to pick a card?
Sure.
Okay. Anyone else want to pick a card? Want to pick a card? Cool. Want to pick a card? Cool. Okay. Get my cards all nice together. Okay, so 5 cards. I'm going to show you first, and then we're going to present them in a fun way for Srini to see. So the 5 cards are as follows. We have this wonderful 7 of clubs. We have a Jack of hearts. We have 7 of hearts. We have Queen of spades. And we have 10 of clubs. Now, for the people who pulled the cards, these are indeed the cards that you gave me, right? No one missed their card in the deck? Okay, I'll go get Srini.
All right, ready for me?
Yep. Okay, the first card is the 7 of clubs. The second card is the Jack of hearts. The third card is the 7 of hearts. The 4th card is, and this is the final card that Srini will be able to see, the Queen of spades. Now, everyone think to yourself, you've got to see the card, the 5th card that Srini's going to have. Think it very closely in your mind. Think.
All right. Definitely a clubs. Definitely a clubs. Okay. See, and I'm getting a 10 of clubs.
And it is a 10 of clubs.
All right. Thank you. All right. So I guess I'll have to confess, I'm not a mind reader, but I also did not cheat. Okay? So there's an algorithm here. And do you guys want to know what the algorithm is? So you can go try this out, I guess, when you go back home next or whatever at your dorms or with your classmates. So it's not as easy as it might seem, simply because the combinations aren't really in our favor, right? So if you think about it, there's 52 cards. So this is a regular deck of cards. You know, so as I said, there's no cheating here. Billy showed me 4 cards. So, which means the fifth card could be, 1 of 48, right? I mean, it's completely random. You guys picked these 5 cards completely at random, so there's no way that that fifth card could be anything specific, okay? So what Billy had to do was, in the 4 cards that he showed me, he really had to communicate one of 48 possibilities, which is kind of, if you think about it, the math doesn't quite work out, right? So if you just say, so what are the ways, how much information could you imagine communicating in terms of bits of information, right? In terms of possibilities or bits. How much information do you think that Billy could communicate in these 4 cards, which were also picked at random? Obviously, they have to be specific cards, right? He just put them up there, right? So if I have 4 cards, what are the ways that Billy could communicate information? I mean, you saw what he did. Any ideas? Yeah, Gunatra?
The order the cards are placed.
The order the class are placed. So that's a great answer. But if you look at the order in which the cards are placed, how many different orderings are there? 4 cards, how many different orderings? 4 factorial, right? And that is 24, right? So I'm not quite at 48 yet, right? So that's a bit of a problem, right? So is there something else going on other than the ordering? Yeah.
Maybe like the type of the rank that we know that we have 4 reads.
So you mean the way he put them up, slowly versus quickly, or did you mean something which was the time in terms of the exposure of the cards, or?
I'm saying we have different variations. Like for example, so I mean, we have like the 4 factorial ordering, but we also can display them, for example, according to like color, like red or black, and like different combinations or maybe.
Well, but that's all part of the ordering. I mean, you have to be a little careful here, in that, I mean, you can't do both, right? I mean, you can't constrain the ordering and then say that there's 24 different orderings. The moment you constrain orderings, the number of orderings shrinks, right? So I will say that, as I said, this is a very legit trick. It's completely algorithmic. We're going to write code for it, or I'm going to show you code for it. But there's nothing else other than the ordering, okay? There's no sleight of hand. There's no hidden communication. He didn't stress words. Clubs meant something, or spades meant something else. It was just the ordering, okay? And so there's a gap here in terms of 24 and 48, right? And so what's cool about this trick is we're actually going to be able to do this original trick where the 5th card could be 1 of 48, because we're going to do one thing that you probably didn't notice, because we only did the trick once, all right? And so let me explain how this is going to work with just sort of randomly picking. I'm just going to pick the top 5 cards, assuming these are shuffled, and you can assume these things are at random, right? So I have 5 cards that I've picked here, and can you all see them, right? Okay. What do you notice about these 5 cards? Anything? Yeah, Fadi?
So we have like 4 types and 5 cards, so at least there's one type that's repeated twice, and that can be encoded.
Right. So you're saying the suit, right? So it is clear. I mean, this is true here. You have the 7 of clubs and the 10 of clubs, right? Were these the cards that you pulled out or close? Anyway, so they look pretty similar to the ones we used, but that's probably just because we didn't shuffle the deck. But obviously, if you have 5 cards and you only have 4 suits, I guess you could call it the pigeonhole principle from 6042, but you're definitely going to have a pair of cards that are going to be of the same suit, right? I mean, there may be more than 2 cards of the same suit, but you're guaranteed for any 5 cards, let me just pick another 5, that 2 of them are going to be of the same suit, right? That's pretty much guaranteed. And so we ended up getting clubs again here. And so you have 2 and 4 of the same suit. So the first thing that happens in this trick is we use the first card to give away the suit, right? Or Billy used the first card to give away the suit, all right? Doesn't quite finish the story here, because let's just say that I'm going to use the first card to signify the suit. So in this case, let's just say I'm going to do clubs. Now I have a choice here. I could Billy could have hidden 2 and showed me the 4 of clubs as the first card, right? Or vice versa, right? And keep that in mind, because that's actually incredibly important, right? But if you just say that the first card is going to signify the suit, then let's say the suit is now out of the picture, right? So I know the suit of the card. How many? So I have 3 cards left, all right? And I got a hidden card. I know the suit of the hidden card, but that card could be the hidden card. How many possibilities are there for the hidden card now? How many possibilities? I mean, this is all at random. Well, 13. Oh, good point. Good. So this is exactly why I need attentive students. Okay, good. So there's 12 possibilities, since one of them was shown, right? So did that help us? There are 3 cards left, and so how many different? I mean, the first card is the first card, right? So it's no longer part of this permutations. I can't count it in terms of the permutations. There's only 3 cards left, and certainly those 3 cards could be ordered in a certain way. But how many combinations or permutations are there of 3 cards? Only 6 permutations. So again, I seem to have a problem here. I don't seem to have sort of solved the original problem of the 24 to 48. I still have a 6 to 12 gap, right? So we're going to have to somehow cover that gap, all right? And any thoughts? I'll give you a little bit of a hint as to how this gap is going to be covered when I talked about the 2 and the 4. How am I going to cover this gap? The 6 to 12 gap, right? Yeah, Kanishka.
Possibly by saying odd or even. So if the next card, if you can say if it was going to be odd or even, you can shrink it down.
But you mean Billy is going to say something?
No, he is going to present the next card.
Yeah.
Whether it's thinking that the final card that you have to guess is going to be odd or even, and he can shrink down the possibilities of the next card.
So I mean, the only thing he can do is give me an ordering of the remaining 3 cards, right? Yeah, go ahead. Kevin, right?
Yeah, maybe
Yeah.
you could use the cards to make a low to high limit on the range.
That's good. A low-high limit on the range. Exactly right. So what's happening here is not only do I have the first card, and it's not that the first card is just giving me the suit. I mean, that's the way I said it, right? But the first card also has a number on it, right? The first card has a number on it. So that number could be an anchor that is going to help me figure out what the hidden card is, right? And what's important to understand, and this is really the last interesting point with respect to shrinking these possibilities or these permutations down, is you want to think about let me draw this out properly in a nice little circle. You don't want to think about just an ascending sequence of cards or numbers. You want to think about this as being circular, as you'll see, for the following reason. right? So let's just say the ace is a 1. And so we're going to think of that as being the smallest number. So you go 1 through 13 in this case. The king is the 13. All right? So that's your number. And so you could imagine you go 1 through 13. So let's just do that first, and then I'll explain to you why I drew it in a circle. And the first thing that happens is I'm going to take some card here, and I'm going to make that the first card, right? So I don't care about suits anymore. And if I just picked another 5 cards, let's just do this again with another set of 5 cards. And what do I have here? Oh, I got all mostly hearts. Okay. So let me do something more interesting. There's just too many hearts there. Right. Let's do this. Right. So now I got a 2 and a jack, and I got a 10 and an 8. Okay. Now I'll make this even more interesting by picking. I want to get a hearts card, and let's see how this works. Finally. All right, so this is what I have. King of hearts, 8 of spades, etc. So the 2 cards with the same suit are the 2 and the jack, right? And so here's the important thing. One of the things that Billy did, kind of in a subtle way, I'm assuming, and some of you may have picked up on it, the very first card that he asked one of you to pick, it certainly wasn't the hidden card, right? I mean, he got all 5 cards, and then he decided which of the cards was going to be the hidden card, and then took the remaining 4 cards and encoded them, right? And if you don't do that, if you just say this, so this trick won't work if this is the hidden card, okay? This trick is only going to work, as it turns out, if the hidden card is a 2. It won't even work if the hidden card is a jack, okay? And there's a reason for that, all right? And can you think of the reason for that? If you look at the board, can you think of the reason for that? Someone other than Fadi? Someone else? What do you see up here? So what am I trying to do in terms of what would happen? You guys talked about, Kevin mentioned the distance and things like that, right? You can call it the offset. So what would happen if I hit the jack and I did this, I did something like this where the 2 of diamonds was the first card that was put out, and then I tried to encode a number using these remaining 3 cards. What's the biggest number that I could encode? I mean, I need to encode lots of numbers, right? So what's the biggest number that I could encode here? If I had 6 permutations and I start with 1, the biggest number that I could encode is a 6, right? Sadly, the jack is too far away from the 2, right? If I think of the jack as being an 11, it's 9 away from the 2, right? But help me out here. What could I do? If I flipped it, what happens?
Couldn't you just count backwards?
You could count backwards, or what do I have up there on the board? What do you see up there on the board? I wrote something that was linear, but what do I have up there on the left? Circular. So you think mod arithmetic. Think of this as being circular, okay? So what happens is that if I picked a 2 and a jack, what I want to do is to go clockwise, okay? And because there are only 13 cards, for any pair of cards, it's always the case that I can choose the first card in such a way that the hidden card is at most 6 away from the first card, okay? Because you could get into a situation where, obviously, if I ended up hiding the jack and exposing the 2, I end up getting a 9, which is impossible to encode. But if I hide the 2 and expose the jack, then I go 1, 2, 3, 4, and I'm at basically 4. Okay? So that's the last thing. All right? So let's just do this really quickly with yet another set of 5 cards. Right? Now, obviously, we practiced, so we could do this fairly quickly. Right? But and you can practice too. But sometimes you get lucky, and you get easy things to encode, right? So what happens here? So now that you know the algorithm, you have some choices here, but obviously not all choices will work. You got to be a little bit careful. What would you hide? So you need to make sure that you can choose a pair of. I'll make this a little bit easier. Sometimes choices make things more difficult, right? Perfect. All right. So what you see here is you know that you have to do the clubs now, right? Because you have the clubs as being the suit that's repeated. No other suits are repeated, right? What am I going to expose and what am I going to hide? That's your first question, right? Someone else? You guys are all going to have to do this trick. That's the final exam for this class. Okay, on Friday next week, you're all doing the trick. No, right? So what am I going to? Yeah, go ahead, Josh.
You're going to hide the ace, and the king of clubs will be the first card.
You're going to hide the ace. Exactly right. You want to hide the ace because you want to go this way, and if you do it the other way around, it's not going to work. You're going to hide the ace, and you're going to make the king the first card. And now what you need to do, this is gone, right? And now what I need to do is I need to encode a number between 1 and 6 in general. In this case, I need to encode the number 1, okay, in order to give away the fact that the hidden card is an ace. And now I could do what was suggested before, which is have some sort of, there's obviously an ordering associated with these cards that you see up here. If I call this a 1 and I call this a 13, then let's do the logical thing, which is 1 is smaller than 2, which is smaller than 13. But I might end up, I might have a 9 of hearts here rather than a 5 of hearts. And I got to obviously be able to order the 9 of hearts in relation to the 5 of hearts as well, right? So because all of these could be 9s actually, right? And so I can't just rely on the number to do the ordering. So I could just choose an arbitrary clubs is the smallest, diamonds is the next, and then I got hearts. I just did this because this is a little bit easy to remember for me. You can do this in many different ways. In alphabetical order, C, D, H, S, and so that's moot here. What I need to do is to encode the number 1, okay? And when I in order to encode the number 1, I have to have some sort of way of ordering this. And so what I'm going to do is I'm going to say SLM is 1. So what do I mean by SLM? The smallest card is first. SML is increasing. My bad. The smallest card is the first one. The medium card is the second one, and the largest card is the third one. Okay, and I'll write this out, and you can see the code for it. But when you see something like LMS, you're going to get a 6, and there's obviously 6 of these different combinations, right? The details are actually entirely up to you. I mean, the most important thing here is the ordering that Billy had to be the ordering that I had, all right? And so yesterday when we practiced, at one time there was a mismatch, and we got it wrong. But that's the only way the trick would fail, it really. Other than human error, is if the encoding, this is really encoding followed by decoding, and obviously you need the same algorithm, if you will, which requires that you need the same ordering in this case for the cards, right? So that's it. That's the trick. It doesn't seem that interesting anymore, huh? But no, it is interesting if you show it to people, and the fun part is in actually doing it. So I encourage you all to do it. Any questions about how this trick works? So what I'd like to do is show you some code for this trick. And there's also a code that was useful to both of us because we could practice by ourselves. We didn't have to be in the same room to practice because I could sort of randomly generate a bunch of these 4 cards. And obviously, the program knew what the hidden card was. And I could, I'll show you the code. I could type in what the hidden card was, and it would say, I guess it would say, you're a mind reader extraordinaire, or sorry, not impressed. And Billy could do the same thing in terms of checking his encoding. All right. And then after we're done here talking about the code, and there's some interesting things with the code, let's talk about whether you could talk about different kinds of tricks. And in particular, I want to talk about whether we could go from 5 cards to 4 cards using a different encoding scheme, right? So, cool. So, I wrote this code about a year ago, and I think I'd probably write it differently now, but we have what we have. So the first thing is you have to decide on an order, right? You absolutely have to decide on an order, and the cards themselves, as I mentioned, there's a natural order associated with the numbers, and of course you can decide if you want to start with the 2, and then and the ace could be 14. I mean, it kind of makes sense for you to go 1 through 13. So that's really what we have here. The ace is the smallest card, and the king is the biggest card. And as I mentioned, the clubs are smaller than the diamonds, etc. So I just have a deck of cards that is ordered as you see up there, and that's just a Python list that tells you what the ordering of these 52 cards are. Right? That makes sense? There's many procedures here, many routines that do different things, and a lot of them use the same code, so I'm not going to explain each one of them. But this one is a good one, and I'll also show you the computer assistant one, which is essentially this procedure, except that it allowed me to practice by myself and generated cards randomly. In this case, what happens is you input 5 cards, and what this does is, so you could sort of take 5 cards out from the deck, and then manually you can choose the hidden card, order the remaining 4, and if you typed in those 5 cards into this particular procedure, it would give you the first 4 cards, okay? And so you can then verify that you've done the ordering. So this would be something that, I don't know if Billy used this to practice, but he could have. So what do I have here? Well, the first thing is just printing out what the order is. There's a bunch of things that need to get initialized. Cards is simply a list of 5 cards. And then you have index or ind, which is the indices in that giant list that we have that had 52 cards in it. They're just the indices of the various cards. You can use .index, which is a method to go from a card, which is like A_C, for example, to the index. And then card suits are what the suits are for the cards, and it's 0, 1, 2, and 3 for clubs, diamonds, etc. And then the numbers are what the numbers of the cards are, 1 through 13. Okay, you kind of need there's a bunch of bookkeeping, as you can imagine. We're doing things in our head here, but if you want to get a computer program to actually do all of these computations, it's not complicated. But you have to worry about the 4 suits, and you got to worry about the 13 cards, and you have to go ahead and encode SML or produce this encoding, right? So you can imagine there's a bunch of code. It's not complicated code, but there's a bunch of code, right? So the first thing that happens here is in this particular procedure, you want to input these cards in. And so let me just run it, and so you get a sense of what this procedure does. All right, beautiful. So let's just say, let me just pick 5 of these here. So first one is 5 of hearts. I'm sorry, 5 of hearts. Yep, 5 of hearts. 9 of diamonds. Jack of spades. 10 of hearts. And 8 of hearts. And so it essentially says the first, so if I have something like this, it ended up choosing the 10 as the hidden card, and decided to choose 5 as the first one. And then because 10 was the hidden card, you needed to encode 5, right? And so the way you encode 5 is by encoding L, S, and M. So the first card that should be up is a jack, followed by the smallest card, which is an 8, followed by a 9. Okay, that's essentially it. So now that you've seen that, let's take a look. I'm not going to go through every line of code here. I want to point out a couple of things that are interesting. This is simply filling in that data structures. The only thing that's interesting here, or the thing that's probably the most interesting here, is what I've highlighted. This is a way of taking an element in a Python list and getting the index for it. And so that's essentially something that it's object-oriented programming. We probably won't get into that in this class, but you'll definitely see that in 009 and other classes. And essentially what we have here, given the ordering, is the suits simply correspond to whatever the index is mod 4. Because as you can see from this, the clubs are, this is 0, the index 0, and the next club is index 0, 1, 2, 3, 4. So you're going to get mod of clubs is always going to be, mod 4 of clubs is always going to be a 0. Mod 4 of diamonds is always going to be a 1, etc. Right? So that's essentially what happens here. And the first thing I need to do is figure out 2 cards that have the same suit, because that's important, because that's going to determine what my first card is and what my hidden cards are, and that's what happens over here. And then once I have that, I've sort of split these 5 cards into 2 piles, one of which has the hidden and the first card in it, and the other pile has the 3 cards that correspond to the ordering in it. Obviously, the computations that I have to do for the first couple are quite different from the ones for the remaining 3 cards. In one case, it's ordering. In the other case, it's a comparison. And I do have to, the most interesting remaining part of the code that I'm going to show you is the determination of what the hidden card is and what the first card is. And that's going to require, this is the part that actually took me the longest to code. I got it wrong a couple of times. It's going to require me, it's 5 lines of code, but it's subtle. It's going to require me to kind of figure out whether it's the jack versus the 2, or vice versa, right? And things get a little bit interesting. For example, if you had, if it wasn't the jack and the 2, the example I had here, so let's put the jack and 2. Let's say I had a 3 and a 10, right? They're kind of the furthest apart, and you have to be kind of super careful here, because 3 to 10 is obviously 7, which is too large, but you need to go 10 to 3, which is 6, right? So the things that are diametrically opposite to each other are usually the hardest when it comes to actually doing the trick. But it was also hard from a standpoint of coding. I had to get the mods right and the subtracts and in terms of what got subtracted from the other. So the rest of it is I just have high-level descriptions. Obviously, the code for these individual subroutines is in the file as well. But this one determines what's hidden, what the other card is, and what the number that you need to encode is. So when you go do the split and you have the 2 cards, you obviously need to decide which one goes first, which one is hidden, and you also get the number, right? And that number had better be between 1 and 6. Otherwise, this is not going to work. And then you remove the other, the 2 cards, hidden and other, from the set of 5 cards. In order to actually do this SML, it was a little easier for me to sort these cards, and then depending on the number and code, I change the order. Obviously, if I sort the cards, I'm going to get SML, and that may not be what I want. But it's easier to start with SML, saying this is the order that gave me the number 1 as an encoding, what do I need to do in order to change that encoding to a 2 or a 5 or a 6 or what have you? Okay? And so that's what this, this output next 3 cards does. So, so this is what took me the longest to code, right? I mean, it was a few minutes, but the rest of it was pretty much busy work. There wasn't too much thinking. So this thing here, as you can see, that encode is don't need to worry too much about the list itself and the indexing into it. The bottom line is I need to figure out this situation, and I need to subtract. And so when I see something that says 10 and a 3, I end up getting a 7, and then I know that I have to do a flip. Okay, but it also may be the case that I might get something that the reason I need the mod 13 is partly because I might end up getting a negative number, right? So it's not clear that encode, take away the mod 13, is going to give me a positive number, right? You know, I might be subtracting a 9 from 2, right? So I end up getting a -7, right? So you don't know this. I mean, the program doesn't know which one is which, and it has to figure out which one is which and flip them together. So if there's any code that you want to look at carefully, it's this code. And it's just a matter of sort of going through the combinations and making sure. I know it works, but you need to convince yourself it works. All right? So that's pretty much it. There's not much more to say here that wouldn't be kind of obvious to you looking at it carefully. So I don't want to belabor the obvious. And output next 3 cards is the part that I just described. You start with sort of the default ordering, which encodes a 1. And then you need to do a little bit of flipping if you want to encode a 3, for example. And if you want to encode a 3, then you change things around. And this is exactly what I described to you before, right? So this is actually fairly straightforward. If you have that table written in front of you, you can just go off and write that, okay? Certainly, if you change the algorithm, you know, all of this would change quite dramatically. And there's an exercise which it asks you to do that, which you could certainly try to do. I want to show you one other thing, which is interesting, and then I want to run this new subroutine. So what I have here is I'm going to run. Oh, I've already run it. So I want to show you Computer Assistant, which was very useful to me. And this says, please give me a random number of at least 6 digits, right? So obviously, I don't want to know what the hidden card is if I want to practice in a legitimate way, right? So what I did was I said, I'm going to have this sort of hokey, I'm just really hokey. I'm going to have this hokey algorithm that's going to take this giant number that I'm going to type in, and it's somehow going to take this giant number, and it's going to deterministically generate 5 cards based on this giant number, okay? But I didn't want to have an obvious way. I mean, I don't want to say the number 1, 2, 3, 4, 5, and then end up getting the first 5 cards in the deck or something like that, because that would sort of give it away, right? So I want to have some sort of obfuscated way of taking a giant number and generating something that was at least unpredictable to me in terms of the 5 cards that are generated, okay? And so what I do is if I type in a number, you know, some random number, and at this point I have no idea what the 5 cards are going to be generated are, okay? This does tell me, it does do the assistant orders cards functionality, so it does take those 5 cards, hides a card, right, and then exposes the 4 cards to me, right? And so I'd get different depending on what number I type. So the way I practiced is I just sort of, you know, close my eyes and just type some random number, and then it would produce 4 cards for me. And notice that this is wonderful. Notice that there's a bug, right? This is exactly why I put this up, and wow, what luck, right? So notice that this didn't work, right? You know, and that's the fix. That's an exercise. I kid you not. It's an exercise that's going to be up there, which is, you know, fix my hokey algorithm so it doesn't do this, okay? And so what happened here was I had a deterministic way. This wasn't a random number generator, The good way of doing this would have been to use Python's random number generator facility and not have me do anything. Because obviously I typed something that turned into that, which is a deck that had two King of Hearts in it. So my deterministic way, which was a convenient way because only 4 lines of code, didn't need me to include the Python random lib library, etc., causes trouble, right? So this obviously won't work, right? So I'll just type something, and it's going to say, sorry, not impressed, okay? Not impressed with my guess and not impressed with my code, okay? So let me do this again. And so let me just do that. And now, what? This is ridiculous. I mean, does my code even work? I'm going to blame it on my computer. I told you my laptop was acting up. Okay. Okay, 111 222. Oh, thank you. All right. So now I see this and I say 7 of clubs. So that's the first card. So clearly it's the clubs. And then 10, king, and 6, right? So 10 is the medium. So I got medium, large, MLS, right? So MLS MLS would be 4, right? So 4 would give me the jack of clubs, right? There you go, right? So this worked, okay? But now I want to show you, the last thing I'll do is show you this code, and you guys should absolutely fix this code. It is clear what your exercise is. Or you could, I do want to talk about doing this with 4 cards. So notice that this is the offending line of code. Okay. So what I did was I wanted to generate 5 kind of random looking numbers out of this giant number that I typed in, right? And I got lazy and I was tired of this puzzle by the time I ended up coding it. So I just said, I don't want to include random.lib from Python. I'm just going to take this and I'm going to do some sort of iterative computation where I'm generating what I think are random numbers between 1 and 52 from this giant number that I typed in. And I'm going to do this 5 times. And what happened, as you saw, is that I generated the same number twice a couple of times, right? And that's why, obviously, the trick doesn't work in that case, right? What was interesting was the way I found this bug was not the obvious way that we just saw here. It was actually something where the hidden card was the same as one of the 4 cards, okay, that was exposed. So I didn't know that, right? So I'm like, what? Why am I not getting this right, right? It kept saying, sorry, not impressed, right? And what it meant was it wasn't impressed with my coding, not with my deductive skills, okay? So it took me a while to figure this out, all right? And you can fix it, okay? So that's it. Any questions about what we've talked about, the puzzle or the code? Right. Okay, so in the 5 minutes that we have left, let's talk about whether there would be a trick which would be perhaps even more impressive, where we would only use 4 cards, right? So it would only be 4 cards that the audience selects, and we would, Billy, I guess, would show me 3 cards, and I'd have to guess the 4th, okay? Would that be possible? I mean, the numbers really, don't work, right? Because that 4th card could be one out of, I guess if you show 3 cards, 1 out of 49 different possibilities, and it would be pretty difficult, right? You could, think about something where the only way I could come up with required much more encoding. But I was thinking about something like this, right? Where, let's say I have these 4 cards, right? And let's say that they're all of different suits, right? Because that's possible. What the other thing that happens when you only have 4 cards is they all 4 could be of different suits, right? That's certainly possible. Oh, I keep. What do I want? I want a hearts. Okay, good. So I have something like this, and now I'm in real trouble, right? I mean, clearly anything that we talked about isn't going to work, right? So let's just say that, that I end up choosing one of these cards, to hide, right? So this ace is hidden, okay? Because it's not quite clear what I can do here, but bear with me for just a minute. So for argument's sake, let's say that now at this point I'm trying to get more information out of this. The ordering isn't going to help me. I mean, the ordering is going to help me a little bit, but what am I going to get? Like 1 through 6 from this? So I could say the first card is an anchor, okay? And so I'm going to expose this. So the only thing I could think of was you could sort of do, this is a little bit obvious and maybe giving things away, but depending on where you have the hidden card, and you can get more information based on the order in which you put these cards out and whether they're to the left or the right of this hidden card, okay? So you need to do something like that. I mean, I haven't figured this out. At least I can't think of a complete solution to this puzzle, but I do feel like that you can get some information, additional information, based on whether you put things to the left or the right, and that's clearly a bit of information that you get, and maybe you could add to that and think about it, right? I think it makes for an interesting exercise, and obviously there's other ways of doing the 5-card trick as well. All right, cool. All right, that's all I had for today. If there are no questions, we can close this particular session.